From this video onwards, we shall start discussing some standard distributions with densities. We shall start with the uniform distribution, abbreviated as Unif, then two numbers a less than b. This is the distribution which is uniform over the interval a to b. Whether it is open or closed or semi-open, it does not matter. The density, because it's uniform, has to be flat, a constant, and 0 outside. And in order for this total area to be 1, this height has to be 1 upon b minus a. This is when x lies between a and b and 0 else. We have already seen this distribution a number of times. Now its CDF is also very simple. I take some x between a and b. The CDF is the area to the left of x, which is this. Again a rectangle. It has got base x minus a and height given by this. So the CDF is x minus a by b minus a, and this is when x lies in the interval. If x lies to the left of a, obviously the area to its left is 0 because it is flat with 0. Similarly, if x is here, then the entire area, the entire rectangle lies to its left, so then it is 1. We can include these equalities wherever we like because we are working with a continuous CDF, but traditionally we like to associate equalities with the left ends. So I will write it in this way. The CDF looks like this. Of special interest is the case when you have a equal to 0 and b equal to 1. This has density equal to 1 here, and CDF also becomes a lot simpler. It is just x when it lies between 0 to 1. 0 here and 1 here. Remember the graph of the CDF, which is useful. Flat 45-degree line up to 1, 1 and then horizontal again. That is the CDF of uniform 0, 1. Now this particular distribution, uniform 0, 1, plays a lot of important role in the theory of probability. We are going to take a look at that, but first let's take the simple properties. We will find out its average, expectation, variance, etc. If x has uniform 0, 1 distribution, then its expected value you can of course find by integration, but it is more instructive to think graphically. From 0 to 1, all values equally likely, so where should the average be? The average should land back in the middle, so it should be half. Of course, you can check it by actual integration. I am integrating x times the density, which is 1 when you are between 0 and 1, and that is indeed equal to half. What about its variance? We will now employ directly the definition, which is expected value of x square minus square of the expectation. Square of the expectation is simple, half square, that is quarter. And what is this? Using the same technique, it will be x squared times 1, 1 is the density, from 0 to 1 dx minus 1/4. This is 1/3, 1/3 minus 1/4, and that will be 1 over 12. Now suppose x is uniform 0, 1. So it can take values from between 0 and 1, everything is equally likely. If I multiply this with 2, what will happen? This will stretch out to 0 to 2. Is there any reason to believe that these values are more likely than these values? No, because originally this came from this and this came from this. If these two things had equal likelihood, so when you are stretching them out, they will still have equal likelihood. So you can guess that this should have uniform 0-2 distribution. Now if I say add 1 to it, what will happen? This will shift everything to the right by 1, so this will become 1 and this will become 3. In this way, whatever uniform A to B you consider, they are all basically scaled and translated version of uniform 0-1. You can of course prove this fact using our Jacobian formula, but it is better to understand it and grasp it intuitively. In this exercise, you have to find out variance of y, where y has uniform distribution from 70 to 73. You can of course employ the definition directly, but I want you to do it in a simpler way, just by mental arithmetic, using the fact that if x is uniform 0-1, then the variance is 1 by 12. So try to create y using x by suitably multiplying x with a number and adding a constant such that the interval 0-1 comes to the interval 70 to 73, and using that guess and find out the variance of y. Also, I want you to find the characteristic function of x. In case you have forgotten what that is, it was this thing, expected value e to the power I t x. X has uniform 0-1 distribution.